Alright, Easy Robot, this is the Jarvis project. This is Josh Starnes. I have the Servo City servo tester hooked up at 6 volts. And as you can see here, I did some linkage going on. I actually bolted this servo horn, large servo horn, through the outside of the elbow. Alright, this is actually not screwed down. This is just for testing purposes at the moment. And then we also have a approximately the same size, I'm pretty sure they're the same, with the same width, using ball joints. And the reason why I'm doing that is just in case it wiggles a little bit. It's not going to do any binding, because if you notice, they're not perfectly the same size. They're off by like a 1/4 inch or something like that, over a distance of about 5 inches. But that shouldn't be a problem. So I'm going to go ahead and show you how it works right now. Alright, slow movements. Again, like I said, this is not fully assembled. It's about as far as I can go one direction. And as far as I can go the other direction. Now basically what I can do is adjust the position of this one, perhaps, or something like that, and maybe move which hole these are in to adjust where it's at a little bit, or maybe just unscrew both of these, rotate them slightly, because he really needs to be able to move this direction, which is up, more so than he needs to be able to move down. And these are a little bit loose, so if it's so loose right here, just kind of wiggling around, it can bind. So let me move that a little bit. There we go. So basically I can't move it beyond this position right here without it binding. And I believe that has a lot to do with these. Just again, they're loose. See, they're kind of wiggling around in there and have a lot of play. I believe I can fix that problem by, tightening all these up and obviously, screwing the servo down. But this is where the wire's going to come out. It's going to have the servo inside here, which is going to open and close the claw. And my mad scientist's brain has some ideas, maybe to turn the claw as well, with about 15 pounds of force, but also keep it light. That's really super important in this particular case. I thought about something doing cable driven with another servo under this one, sideways, cable driven through here, and it bends the cable. So I'm going to try that out, but I'm not even going to show it to anybody unless I get it working. But here's the arm. So I'm just going to do it again with the other, tighten these up. I'm just going to do it again with the other one. Now I have some heavier duty Dubro connections that are for like 1/4 scale aircraft, but these are from Tamiya, and I decided I would try these first, since initially I'm not going to be trying to do any heavy weights. I just want to get the guy moving first. This, I'm estimating he's going to be able to lift a pound or so, no problem with these, even though these are plastic. Because I do seem to be pretty sturdy, and I also have several extra servo horns just in case I screw up one. This is what's called a push-pull system, by the way. Basically what's happening is with a pull, it pulls this direction, alright, and as long as this axis stays in place, which it should, because it's bolted, okay, then what happens is each one of these shares the load. So if there is a 3-pound load, or in this case over, 5 inches, I'm not going to do any math right now anyway, but let's just say it has a load of about 5 pounds. What's going to happen is 2.5 pounds is going to be going this direction, alright, and then 2.5 pounds are going to be going the other direction too as well. And because both sides move simultaneously together, it makes for a very smooth movement. As long as you don't get binded up there. Again, loose screws. But it makes for some really smooth movement. I think it's a good elbow. It doesn't wiggle around. It only has one screw in it. One screw's right here. No screws here at all. Okay, it's just sitting here. and it still fits together pretty good. I'm really happy with it. I want to do another one, and I want to upload this video. It's probably going to be really high in megabytes because it's like 5 minutes long. But I wanted to kind of explain how this works in this push-pull system. Anybody can use this for pretty much anything, but the dual linkages are usually better because they're sharing load, and it kind of makes a more efficient effort from this. These are commonly used in rudders where you use 3D aircraft. 3D aircraft, the rudder's probably gets the most stress out of any of them, and they usually only have one servo. Sometimes they use 2 servos, which is called tandem, with a servo reverser. That way one servo moves one way and one moves the other, but there's a risk of them burning out, like Robot Maker says all the time. And this is a solution to that, with a push-pull system on one high-strength servo, so that there's no risk of anything ever being out of sync, because it's mechanical. So that's just a bit of information for everybody else. You might be able to use this idea in your robot. I'm just going to wrap this up. We'll load it up on Easy Robot, and we're just going to do another one. Have a good night, guys.